Have you ever wondered how aircrafts manage to stay in flight? Well, regardless of what one might think, it is not actually caused by some magical or mysterious force. My name is Reid, and I am going to demonstrate how the principle of fluid dynamics works thousands of feet above the ground on which you and I stand. Now, let's say, for example, I take this sheet of paper, hold it up to my mouth, and blow on it. Did you see how the bottom of the paper rises? Well, why does that happen? You might expect for the paper to remain level with my mouth, right? Well, not exactly. You see, a fluid can be as easily defined as any substance that will always take the form of another object when a state of pressure or stress is exerted on it. Such substances as this are called incompressible because of the law of mass conservation, which says that matter cannot be created or destroyed, it can only change forms. So no matter how much force is exerted on an object, here being a fluid, the original volume of that fluid will always remain the same. Isn't that fascinating? A very influential scientist in the 18th century, Daniel Bernoulli, built off of this concept when inventing his famous Bernoulli's principle to develop aerodynamics, which is the study of the motion of air. He discovered that the pressure and velocity of a fluid are inversely proportional, simply meaning that as the pressure decreases, the velocity increases and vice versa. Now, based on the definition given earlier, a fluid can either be a liquid or a gas, and since air is a gas depending on the surrounding temperature, air can be a fluid. This soon became the foundation for the idea of airfoil lift. When a plane takes off, thrust is created by either a jet engine or a propeller. This causes a secondary wind to flow against pre-existing winds and collide with the leading edge of a wing. Since air behaves like a fluid, the particles of air must also behave like that of a fluid, causing them to flow in currents called air streams. And since the air particles can obviously not flow through the wing, some travel over while others travel under. The upper airstream bends toward the wing, causing a decrease in pressure, while the lower airstream bends away from the wing, causing the pressure to increase. Now, Bernoulli discovered that if the distance over the wing was longer than under, that because of the law of mass conservation, the air particles above would have to accelerate in order to catch up with the rest of the particles at the trailing edge. For this reason, wings are created in the shape of an airfoil, with the top called a camber, to ensure the optimal airflow. Now, the particles flowing over the wing, however, will continue in a downward motion because of Newton's first law, stating that an object in motion will tend to stay in motion unless acted upon by an outside force. Once the air particles above have reached the air particles from under at the trailing edge, it creates a rotational current that actually pushes up on the bottom of the wing, giving the plane the lift necessary to fly and remain in the air. So hopefully, now you can understand why the paper rose to a point of inflection at the beginning of this video, and you can thank Bernoulli for discovering it 300 years ago.